There are chances that right now when you are accessing this application or watching this video, that application behind the scene is hosted on some type of server in some data center. So what are these servers? Let's talk about some of the server fundamental. Server is a box in which you have sufficient compute, networking, and memory and storage. Now, is this not the same thing which is in a desktop? Answer is yes, but servers are little different than a desktop. So let's focus on how it is different and what kind of component are used within a server to ensure that they work as expected. So let's go ahead and talk about server fundamentals here. So how is server different from a desktop? Let's focus on that. So servers are designed to be more reliable than your desktop or laptop. They would obviously be serving a lot of application and everyone wants response faster. So the servers would have fast component or may have performance which is improved. Then they would also be having some component which is redundant, because if your laptop fails, only you get affected. But if a server fails, multiple user will get affected. So we need to ensure that we have redundant component within the server. Then they would also have mechanism to scale themselves, because one server may have a limit to, let's say, serve 1,000 users. What if I need to serve 10,000 users? I cannot keep on creating bigger and bigger servers. Yes, I can, but I need to have a scalable solution in that case. So server would support scalability too. These are some common things which you would be seeing. Now, what are the key differences in the terms of component when we use in a desktop or a PC or a personal computer or in a server, just to give you an idea about it. So when we talk about component would be same. We would have CPU, memory, disk, network, power supply. But when I'm talking about a PC or personal computer or laptop, probably you would have one or two servers or two CPUs in that. Like here it is a dual core, you may have more processor or multiple processor into a server. So that is a very common thing you would be seeing within us. So this multiple processor ensure that it can serve multiple application or run multiple thread at the same time. When it comes to memory, obviously there would be large amount of memory into a server, and possibility is that they are using a very specific type of memory chip which we refer sometime as ECC, error correction code, which has capabilities to ensure that no errors happen. So this is what a type of mechanism within the memory chip which can be there into a server. Just giving an idea, it may be there, it may not be there, but just most of the time you would have server component which are created with a vision that there would be failure and how we can mitigate it. When I'm talking about storage associated, we mostly connect to storage with our PC with maybe a serial ATA or a USB drive. But in terms of server, they may have multiple type of storage like SSD drives, maybe RAID controllers, maybe you would have SCSI connectivity. So it depends. When it comes to networking, your network connectivity would be 1 Gbps, 10 Gbps, 100 Gbps. But in terms of server, it can be more than that, and there may be multiple channels also available, redundancy requirement. Plus you may have fiber optic connectivity also to ensure you can send storage traffic much faster. Again, when it comes to power supply, your laptop may have one battery and maybe one power supply unit, but when it comes to server, you may find multiple units associated with them. Redundancy is the requirement. So that is what could be key differences between a PC and a server. Components are same, but how they are implemented or what scale they are implemented or what capacity they have would be completely different depending on is it a PC or a server. Now, when it comes to server, you may have also hear people talk about that what type of server you have. That is very uncommon discussion nowadays, but in my days we used to talk about these type of form factor of the server. So what is a form factor? Form factor is basically the physical appearance of that server. Most of the old methods were tower servers, then came rack server, which is very commonly used, and I would say these are the most commonly used still today. And then there was an era when blade server dominated the landscape of server infrastructure. But yeah, depends what you have. So tower, as the name says, it is a tower in which you have lot of computing power placed. They may have lot of room for ensuring lot of component can fit in them, like they may have lot of additional slot for attaching disk or network card or maybe other type of equipment, but they are not very storage efficient in terms of space efficient. That is the right word. So they are not very space efficient. So if I have to host a lot of these tower server, it would be a little difficult for me. So then came the idea of these rack server. Rack server ensure ensured that they have smaller footprint in terms of space requirement. As the name suggests, they are designed to slot into a rack or a server enclosure. So these are like a slot, you insert it into a rack, and that's why they are called rack server. And there was a concept, and there still is a concept called blade server. They provide the highest density computing and are aimed at larger processing hungry data center. I'll talk more about these blade server and rack server in a minute. Let's go ahead and discuss that. So tower server, not very commonly seen into data centers, but what you will find mostly is a rack server. Now in front, it may look very small, like hey, it is just a small rack, but it may be a big sized rack. As you see here, it is a having enough depth so that all the component can fit it inside it. So these racks are hosted into something, sorry, these servers which we call rack servers are hosted into this physical location which we refer as a rack. And rack is calculated based on rack unit, so that is U is represented. Most of the time you will find a full rack which is of 42 U, which has 42 rack units in them, means these can host 42 servers of 1 U size. So server can be small or slim as like 1 U. A server can be a 2 U server which is consuming 2 of your U's or rack units, or it could be a 4 U half rack server also. So these type of servers may be there, and through these servers you run your application. And as you could see in the front, there would not be lot of ports. All the connectivity happens from back, like network connection, storage connection, power supply. Most of these things happen behind the in the backside of your rack server, as we can clearly see here in this case. So front would look little more clean and back would be little more cables and entanglement happening behind the scene. Now what else? What is a blade server then? So what companies decided that, okay, I have 100 servers to run, or let's say I want to run 8 servers. Now all of these 8 servers would require a VGA port or a display port. They would require maybe a USB connectivity. Maybe in old days they would require something called a CD-ROM drive so that you could load some software on them or install something on that. Maybe they would need power supply, all of the server. They would need network connectivity. So why to create all these components in every single server? Why don't we come up with the concept of a chassis? And that is where this blade chassis comes into picture. What is a blade chassis actually? Like, hey, let's create a blade chassis, and then within that we can have blade servers installed like this. And this chassis would have power supply, chassis would have network connectivity, and once your servers are connected within this chassis, then you would be able to have connectivity coming to every single unit. Like if you see in this picture, you could see that this looks like a logically segregated section, and that is what a blade server looks like. So in this case, what we are doing, that we have installed a blade chassis first, and within that chassis now we are inserting a blade, and that is actually the server on which my applications would be running. So that is what called a blade server. So I hope this thing is clear. So you have these blade servers, and within that you insert these blades which are actually a server slim. They may not have all the component which is required, like they may rely on component on chassis like power supply, maybe network connectivity. And what is inside a blade server? Again the same type of component, like you could see here. Like here we have our processors, this 1 and 2, these are the processor slots. As you can see here, these are the memory bank which we call DIMM slots. Then we may have other component here, like we have USB port, maybe have Ethernet connectivity, may have fabric connector. You do not see here, like here is the power supply unit. No, there is no power supply. Power supply may be into the chassis, and then it connects from the back plane, and then you have expansion connector, maybe you have other type of connector by which you connect to it. So a blade environment generally has much less of cabling than tower or rack environment, because you are not having, let's say you have 8 servers, so in that you would have 8 cables which are going and coming to your component. But now once in one chassis I could have 8 servers. Now obviously that means I have to have one cable only for the whole chassis, and then it will be distributed logically within the particular environment. So adding a new server consists of simply sliding it into a slot in the chassis. You connect the chassis and then you insert your blades in that. Bladed server eliminate the space issue, but can pose unique power and cooling concern if you are putting making it so much dense, the server, probably cooling can be an issue. Further, when it comes to expansion option, blade servers are a bit limited by the lack of expansion slot, so they may not give you a lot of flexibility of keeping on expanding and increasing. Plus, when you are buying a blade, you are connected to a chassis, and then you may end up into a vendor lock-in. So here you could see that I may have the server added, and now I can have my fan module, input output section, power supply behind the scene. But now if I have, let's say, bought this chassis from HP, the blade which I have to insert in that is again from HP, and blade is costly obviously, but there is a chassis cost also. So if you are looking only to have two servers, then probably it is not a good idea to go for this chassis kind of environment, because you will pay huge cost of a chassis, and then you would be paying the cost of the servers also. And if you are just buying two, then remaining slots are empty, and that may not be very optimal cost of performance for you. So this is what a blade server may look like. Going further, so here is another example of an old unit Dell M1000E chassis in the front. This is how it looks like. So it has 16 server bays. You could insert 8 into 8 servers here. It has USB connectivity, power button there, LCD screen is there, and it is 10U high. So it will consume 10 rack unit within your rack. Then from the back, this is how it may look like. So if you look here, these are multiple power supply for redundancy purposes. These are connectivity, and most of the time it will be exact same replica here also, so that we would have redundancy. And then we have swappable fans. So these are all your fans are here. Then you have your power supply. So 2350 watt hot swappable power supply means while the chassis is running, you have to power supply failure, you could just remove that one and replace it with the another healthy one. So this is how they are created with redundancy in mind. Another thing that probably you don't want to sit into a cold or a very hot data center and perform all operations from there. So you would need a mechanism to connect to these servers remotely. Now, you may think, okay, fine, I would have a Windows remote desktop, or I would connect through SSH to this server. But what if you have to connect before even the operating system is getting installed, or you want to know the hardware information about the server which you have installed? So in that case, most of these vendors have come up with their own remote management software. Like here is a screenshot from HPILO. It is called Integrated Lights Out, and this software is ensuring that we can physically connect to the server and access all its physical properties. Like here I could see I am connected to a IP address. So this ILO card or ILO chip or ILO interface would have a IP address assignment option. You assign a IP address, sit in your desk at your desk, and then connect to it, and you are seeing the interface to control this particular server, as you could see here. And then I logged in, I am connected to that, and then I have options here, like I could see what is the power supply status, are they good, serial number, what is the capacity associated. I could see summary, fan information, temperature, and other information, what storage is associated. So this is on the hardware level information available to me in a browser interface. Then we may be able to perform operation here, like I can access console of that server physically, remote console here. I can mount media. Let's say if you are coming from the old school, you may have media devices like CD-ROM or USB to install operating system. So you could perform that. Network connectivity, remote support if needed, administration related function. So most of these vendor HP, Dell, IBM would have some remote management software associated with these servers, and that will help you to manage these server on the physical level. Then here is an example from Dell something they call it iDRAC system, and that is a similar to ILO, where they are able to connect you to a server and you can perform all these operations as you expected, like remote access, battery status, power supply, temperature, voltage, and other information like console and media. So it depends, but idea is that you do not physically work in data center unless you want to rack and stack those servers. Once the racking and stacking is done, you would move out, connect from your desk to these ILO interfaces or to these network management systems, and through that you would perform maintenance if the need comes out. And obviously they have all mechanism of alerting you in case a power supply fails, or there is a temperature rise happening, or some network connectivity is disconnected. All that type of alert and systems would be there through which you would be alerted in case something goes wrong. So very rarely you may have to visit a data center unless it is a physical component to be replaced that time. Otherwise most of the stuff happens from on-prem, and going to data center floor every day is not something people look forward to. Obviously if it is a day job for them, maybe, but otherwise data center are very noisy, very cold or very hot, and they are not designed for people to sit and work there. They are designed for hosting server, and that's how they may work. So hope this thing is clear. We figured out component associated with server, and then in the next section we will talk about storage. So join me there. Thank you.